Ladies and gentlemen, welcome to another edition of Tech in 10 with Sin. Today I'm going to be taking a look at the SUPERMICRO C7Z97-OCE. This board is really cool board hardware-wise. If you haven't heard of SUPERMICRO that much, it's because they really are in the server realm. They focus on really high quality components in their server range. All their boards are designed in the United States, and this one in particular, and I believe a lot of their server boards are all made in Taiwan, which ensures high quality components and high quality production. This board features a lot of server level components. Not only that, it features a lot of next gen features. It does support 10 gigabits per second M.2 slot, but it also has USB 3.1 capabilities down here on this blue USB 3.0 internal header. That's pretty cool because I haven't seen that on a board yet. Anyway, so we can start off how I usually start off in a review, so we'll cover the voltage regulators first. Now the heatsinks, you can see SUPERMICRO is really trying to get into the gamer sphere / overclocking sphere. They have a bunch of buttons down here, we'll cover in a little bit, but they've also colored their heatsinks. These are anodized aluminum, and these are orange, and you see the blue. I kind of like the contrast between the blue and the orange. Some people might not, but I actually don't mind it. I kind of prefer it, actually. It's one of my favorite color combos. Anyways, so I'm going to zoom up in here and see if we can get a nice view of the voltage regulator. You can see the VRM is made up of 6 phases. Okay, so I already loosened this up. Plastic push pins hold down this heatsink. We would have preferred screws, but plastic is okay. The VRM heatsink probably isn't too important on this voltage regulator because the quality is very high. Now, when I said server level components, I wasn't joking. SUPERMICRO is not going to use normal MOSFETs, stuff like that. They have used stuff like IR in the past, Volterra, the high-end stuff. Anyways, these are Infineon made driver MOSFETs. I believe their model number is TDA 21215. So 21215. And I cannot find a data sheet on it. I believe a 212202217 is like a 50 amp or a 40 amp part. This has to be at least 35 amp because that's like the lowest driver MOSFET I've seen. Maybe even up to 50 amps. These chokes are made by Vitec and they're capable of up to 45 amps. Now the PWM is made by a digital PWM maker that probably none of you have heard before, called Primerion, and Infineon acquired them a few years ago. Anyways, this model is the PX3746. It's a 6-phase digital VRD 12.5 certified PWM. Okay. Anyways, we see a CPU fan header. There are 5 fan headers on this motherboard. This is the power button. Very odd location. If you're wondering what this connector is, this is because this is an engineering sample board. The rest of the hardware is the same, but this is a JTAG connector. It's for testing the voltage regulator on the motherboard. 2 more fan headers, so 3 of the 5 are up here. 4th one is right here next to the memory. Now the memory VRM is also made up of the same Infineon MOSFETs and PWM, except this PWM is a PX3743. It's either a 2 or 3 phase digital pulse width modulator controller, and it's very high quality. And not only that, but they're extending digital power control to their memory, which to me is a good move on their part. If they're trying to get in the overclocking realm and trying to be good for gamers, they have to have really good power management, and they're definitely doing that. Anyways, we can move on down a little bit. Now, I said there are a lot of jumpers on this motherboard. I wasn't kidding. Okay, so this right here is a built-in speaker. But also right here you have jumpers here. These jumpers, I believe this one is for Mi recovery. So if you want to flash the Mi firmware during a BIOS flash, you literally have to move this jumper or set something in the BIOS. Now this is also used for BIOS recovery, this switch right here. There are a bunch of switches and a lot of them have to do with BIOS recovery. It's kind of cool. There's a lot to learn, and that's why you should read the manual for this board before touching any of the jumpers. Honestly, I would. Anyways, let me take off this bottom heatsink right here so we can go over some of the other features. I want to take a look at this all together. Anyways, so I have already unscrewed this a little bit. The PCH heatsink uses screws, and to be honest, the PCH will get hotter than the VRM altogether will. So they're using actual thermal paste on this heatsink, which is kind of good. Well, actually not kind of good, it's pretty good because I don't see many other manufacturers using it. So you can ensure the cooling is going to be adequate. Anyways, so let's take a look at this section of the motherboard. A bunch of jumpers. Now this right here is an ASM 1061. It's a 2-port SATA 6 gigabytes per second controller. Anyways, that one is hooked up to these 2 ports, and then M.2 takes 2 ports, and then the rest of these 4 come from Intel native. This right here is an extra SATA power connector. I believe it's labeled SDOM or something like that. Now, if you want to run special SATA protocols, you need this power connector, and they're sure to provide it to you. They do this kind of stuff. It's basically server level stuff, and it's quite impressive. PCH power comes from this point of load device. I believe it's a Z123201. I couldn't find a data sheet on it, but it is from Infineon. As to the markings, provides PWM power to the chipset. Anyways, you see they did include a postcode display, and there is a little chip here. What was the model number on that? It's a LC14A. I believe I've seen this before, and this is used to either do the postcode. It's just a bunch of inverters. Just do the postcode or help with the buttons. And if you're wondering what an inverter is, it's basically what you think it is. So if a signal comes in as a 1, an inverter will change it to a 0. If a signal comes in as 0, an inverter will change it to 1. It's a very basic type component in Cmos design. Anyways, this has like 4 inverters inside of it. So it might go to the buttons, it might go to the postcode to invert hexadecimal numbers, stuff like that. Anyways, we also have a little BIOS chip right here. It's 128 megabits. The only manufacturer I've seen use this is Gigabit. This is a large 16 megabyte BIOS file, so if BIOS takes a long time to flash, it is because it's a big BIOS. Anyways, that's a good thing. Right here we have our front panel connectors. They're labeled, but I believe the labels are like up here or something. We have a bunch of buttons. This is the home button. This button will load your own OC profile. This is like a 20% overclock, and this is a 10%. This is a BIOS restore button, so I think if you have like a USB drive in there with the proper files, it'll flash to that. This right here is a clear Cmos button, and this right here is a memory OC button. So it'll overclock to a memory profile, such as XMP, or maybe even one you set. There are more jumpers here. I'm not going to go over all of them because there are a lot. Let's go over the USB 3.0 implementation. This is actually 3.1 or 3.0. Now, this runs off ASM 1042, not native Intel. But anyways, what's interesting here is that they're providing 2 PCI Express 1 lanes from the PCH to this chip. And that's what allows it to do 10 gigabits per second. Normal is 5 gigabits per second. So you add the second the second PCIe lane, and you're basically up to the same speeds as M.2. Their M.2 port also uses 2 ports, which is also kind of rare. Most of the time it's only 1, plus a SATA bandwidth should give you 10 gigabits per second. But anyways, they're using 2. Back to the chips. We have a Nuvoton NCT6776. D in this very common Super I/O controller. Right here we have a PEX8605, and that takes 1 lane and distributes it to these 3 1x lanes. Now they look like 4x lanes, but they're open slotted at the end, so you can put a bigger card in there. If you're doing like folding or something, then that's perfect for you because you can just use the 1x of these slots for a GPU if you want to. But anyways, they're 1x slots, they're not actually 4x slots. Even though they're wired for 4x, they're just literally just 1x of bandwidth each. And this PEX chip distributes it. The bandwidth on the PCIe lanes is as such. So if you're running single card, this is 16x. If you're running 2 cards, I believe this is the 8x. Yeah. No, wait. This is the 8x, okay? And this is the 16x. So 2 cards, 16x, 8x, 4x. These are how they're physically wired. They all have 16x worth of pins, but this is 16x, 8x wired, 4x wired. So this is how it works. 2 cards, 8x, 8x. 1 card, 16x. 3 cards, 8, 4, 4. Okay? If you do this one and this one, it'll still be 8, 4. You lose 4 because you're not using this slot. So 8, 8, oh, just 16, 8, 8, 8, 4, 4. Okay? And these are 1, 1, 1. The black are 2.0, the blue are 3.0. Okay, moving along. And they're controlled by ASM switch chips. So going to the audio section, now you see all the other manufacturers doing some fancy stuff with their audio. Supermicro likes to keep it basic. So they have jumpers on this motherboard to basically disable everything. So I can disable SPDIF output through this. I can disable USB controller. I can disable USB hubs. I can disable a lot of things like LAN controllers all through jumpers, which is pretty cool, especially for overclockers who want to disable extra utilities they're not using or extra components. Anyways, this is the ALC 1150, what most people seem to prefer nowadays. But you see how clean their audio section is on the PCB here. That leads right to the output TOS link. Yeah, it's a TOS link, and that's pretty impressive. Anyways, moving up here, that's a I believe. No, this is a controller. Sorry, my bad. I was under the impression for a second in my mind. I don't know why, but I was thinking that it's a USB 3.0 hub, but it's definitely not. Okay, this is an Intel NIC. This is the i210, and there's a i217 somewhere around there. Yeah, there's the i217. Okay, so this is the i210, and this is a gigabit NIC altogether, and this is the physical layer device, the i217, which complements the NIC built into the PCH. So these give you dual Intel NIC. Now this is the way to do dual Intel NIC on any Z97 board, and they're doing a pretty good job with that. And you see the jumpers next to each one of them. That means you can disable them manually if you so choose, for security purposes or whatever. I believe that actually covers almost all of it. There are some level shifters hiding. Well, there's one level shifter hiding back here that just changes HDMI, digital display signal to HDMI. It's an ASM chip, maybe like a ASM 1442, something like that, or 1442 perhaps. Okay, so let's take a look at the back panel I/O. Okay, so the back panel I/O, remember we have the two Intel NICs, right? Let me make sure the focus is good. Okay, now we have DisplayPort here, HDMI, we have DVI, VGA, USB 2.0 for a failsafe, PS/2 for a failsafe, USB 3.0, all Intel native, and TOS link. So it's very basic, yet very good and very equipped for anything you might need. Now, this board is pretty cool and impressive. The hardware on here I would rate as really high quality. It's a 6-layer PCB. The black is true black. There's no brown in this PCB. So I would say Supermicro has done a really good job with this board hardware wise. And if you're in the market for a really good board with really stable components, you should check it out. Also, I did a little intro of the UEFI. You can also find it on my channel. And yeah, that's about it. It's actually Supermicro's first UEFI, I believe. So they're working out some of the kinks right now, but it's actually not so bad. Anyways, so thanks for watching, and have a good day.